All right, welcome to math. It's Wednesday. Today we're going to back up a little bit. We've been working on how to actually do some subtracting. Now we're going to kind of combine a little bit of being able to do real problems and the idea of estimating that we did earlier on. So if you go to page 145 in your book, so you have to go back a little bit. And on that page, it's talking about problem solving, estimate, or exact answer. Now, we talked about this a little bit in a previous lesson. We're going to do more with it today. Now, I'm going to do lots of examples. Please listen to the explanations because a lot of times it's going to have that word explain, and you're going to need to know how to explain. And I know some of you don't like seeing that because you know you have to write a little bit, but it's just think it through what you did, and that's how you explain it. All right, here we go. This problem says, to celebrate Arbor Day, British school district planted trees. The high school students planted 1,536 trees. The elementary students planted 1,380 trees. About how many more trees did the high school students plant? All right, now, in order to do this, we have to know certain things, like we have to know that the high school students planted a certain number of trees. Well, high school students planted this many trees. So I need to make sure I know what that information is. Elementary students planted 1,380. What do you need to find? Well, we need to find, and that's always the last question here, about how many more trees did the high school students plant? And since they're the ones we're finding out how many more, they should have the bigger number. Remember, we said anytime you're comparing or using how many more or how many fewer, you're going to subtract. So we know we're subtracting. Since this number is bigger, it's going to have to be on top. But I don't know if I have to go through the process of doing the entire actual problem, or can I just estimate? Well, it says an exact answer is not needed. I will estimate. And hopefully you realized because it has the word about in it. I don't need the exact answer. So here's what they're going to do. To solve it, they're going to round each to the nearest 100. Now, some of you might say, but Mr. Springer, you always like doing it to the nearest 1,000 if it goes to thousands. And you know what? I'm going to say you are correct. But in this case, because these two numbers are pretty close to one another, 1,536, 1,380. An estimate using thousands wouldn't really be the best one, because here's what would happen. 1,536 would be almost 2,000, and 1,380 would be almost 1,000, and it would tell me that my difference is about 1,000, and that's just kind of too big of a difference when I look to see those are kind of close to each other. So instead, we're going to do it to the nearest 100. All right? And when they do it to the nearest 100 and subtract, well, it's only 100 away. And hopefully some of you were noticing that if you kind of covered up those zeros, you're actually just doing 15 minus 14, and then you just add the zeros on at the bottom. All right? Okay. Now, it makes sense because my estimates are correct, right? And it would tell me that the high school students definitely planted about 100 more. Okay, now that's when it has the word about. Sometimes it won't have the word about, but we might be able to get away with an estimate anyway. Let's look at the next one and see if it's going to be true here. All right, on page 146, it says students in grade 2 and 3 wrote 61 stories to celebrate Author Day. The second graders wrote 26 stories. How many stories did the third graders write? Okay, now, this is one of those problems where people don't take the time to read everything again, and they look at it and they go, I don't know what to do. Because they're looking and they see a 2 and a 3 and a 61 and a 26, and they're getting all those numbers, and they go, I don't know what to do with them. Well, here's what you do with them. You read the problem a second time. Students in grade 2 and 3 wrote 61 stories. So if I take grades 2 and 3 together, that's the grades, 61 stories were written. The second graders wrote 26 stories. Now, if I take away just the second graders, they wrote 26 stories. How many stories did the third graders write? Oh, now when I look at it and I see what I actually did, I took away my second graders and then stories they wrote. I'm going to be left with whatever the third grade wrote. Now, can we just estimate or not? Well, it says, how many stories did the third graders write? Well, it doesn't have the word about in there. And it sounds like it's asking me to tell them exactly how many they wrote. So what I'll have to do is I'll take my combined number, 61, and I'm going to take away from it just the number that the second grade wrote, which is 26. So now, 1 minus 6, I can't do that, remember. Don't write a 5 here. You can't do 1 minus 6. So I will have to go next door and regroup. Now I have an 11 minus 6, which is 5. And then 5 minus 2, which is 3. So I think they wrote 35. I could check it by adding 35 and 26. And if I get 61, I would be correct. And that could be my checking of my answer kind of toward the bottom. Now, I didn't use all my page here, I realize. But you listen to me find the facts, right? The number of stories in just one grade. We made a plan that we were going to subtract those from the total. And then we actually did it, and that was the solving. Okay, so we don't really need this much space to be able to do it and to think through it. Okay, let's continue on. Let's do some more. Now, remember, really listen to how I'm thinking through the problems and follow along on your own. Remember, you can pause this at any time if you want to write some things down to catch up. All right. This says, determine whether each problem requires an estimate or an exact answer, and then solve it. Okay. Michael Ann cut 2 lengths of rope. One was 32 inches long. The other was 49 inches long. Will she have enough rope for a project that needs 76 inches of rope? Explain. Okay, well, she cut 2 ropes, it sounds like. So if I make the rope over here, one of them is 32 inches long. And then she cut another one, it was a little longer, right? And it was 49 inches long. Now she's going to do a project, and she has to have 76 inches of rope. Okay, it sounds to me like I need to take the 2 pieces of rope that she cut and add them together to find out if she's going to have enough. But do I have to find an exact answer? Or can I just estimate and be able to think about my numbers to get the answer? Well, I could do the exact answer. I could take 49 and add 32 to it. But listen to how I'm going to think through this. 49 is about 50. Now, I added 1 extra inch, right? 32 is about 30. But to get it, I took away 2 inches. So I'm actually saying there's less rope with my estimate than there really is. And my estimate says 50 plus 30 is going to be 80. She needs at least 76, right? She has about 80. Hey, look, my estimate can totally just work on this one. So now I'm going to answer the question, will she have enough rope for the project? Yes. is my answer, because it's just asking, will she have enough rope? So I don't need to know how much rope she has. So that's why I don't like doing the actual problem. I don't have to know the exact amount of rope she has. I just need to know, does she have enough? I'm going to say yes, because I estimated that she has about 80 inches of rope. And there's my explanation. So this one, I could have kind of done it either way, but because it doesn't want an exact answer, it just says, give me a yes or no about this. Does she have enough? I'm going to estimate. So when there's yes, no's, sometimes an estimate's just a quicker way to do it. Let's look at this one. This one is going to be super duper confusing unless you read it a couple times and know what's going on. Here we go. The number 7 septillion has 24 zeros after it. Now, I don't like the problem because they didn't explain what it was. It means the 7. So that means if I'm going to write the number 7 septillion, it's going to look like this. A 7 and then 24 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There they are. Now, if I wanted to, I could go 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. Those are my different periods with my place values, right? 1, 2, 3, comma, 1, 2, 3, comma. There you go. There's 7 septillion. All right. Now look at this. The number 7 octillion has 27 zeros after it. So the it again is the 7. So if I wanted to make that one, I would do the same thing, except for it's going to have 3 more after it. Now notice what I did. I'm just trying to make sense of these numbers. I haven't even read what they are asking me to do yet. I'm just making sense of the problem. Okay, well now let's see. Now that I understand what 7 septillion is, and 7 octillion is going to have just 3 more zeros. Notice I put a line. Here's the end of the septillion. There's octillion. Let's see what they want. How many zeros is that altogether? Okay. Did it use the word about? No. Is it asking a yes/no question? How many zeros? Yes. There. No, that doesn't answer. That doesn't answer it. It looks like it wants the exact answer, doesn't it? So I will need to take the words all together to realize that I'm going to add all my zeros together. So I've got 24 zeros in one number, 27 in the other number. 7 and 4 is 11. Looks like I'll have 51 zeros. Now, I need you to realize something. I'm going to write that answer. There are 51 zeros as my answer. But then look, there's more stuff. I can't stop and move on to the next question. I need to read what this says. What is the difference between the number of zeros in 7 septillion and 7,000? Ooh, wait a minute. 7 septillion and 7,000. Oh, this is a new number, isn't it? 7,000. But we know how to write that one. They don't have to tell me how many zeros there are. 7,000 looks like this. 7, 1, 2, 3. So there's 3 zeros in 7,000. 7 septillion had 24. What's the difference? Well, the difference is the answer to a subtraction problem. So it looks like I need to take my 24 zeros in 7 septillion, take away my 3 zeros in 7,000, And that leaves me with 21. So the difference is 21 zeros. Okay, now I really had to take my time there. I had to think about it, read it carefully so I knew what was happening. Make sure you're taking the time to do the same thing. Let's look at another one. 3 buses can carry a total of 180 students. Is there enough room on the 3 buses for 95 boys and 92 girls? Explain. Okay, so it looks like we got 3 buses, and if you put all the kids together in those buses, it'll be 180. So I've got like 1, I like to make pictures. 2, here's my 3 buses. And if I add all the kids together, they can all fit in there. It's 180. Is there enough room on all 3 buses for 95 boys, 92 girls? Well, this is one of those yes/nos. Is there enough room? Yes, there is. Is there enough room? No, there isn't. And when it's yes and no, I can usually estimate. Let's see what happens. 95 boys is about 100 boys. 92 girls is about 90 girls. Well, if I take 90 and I add the 100, I would get 190 kids about, which means that there's really not enough room. Now, here's another way I could kind of think of it. What if I said to myself, let's ignore the 5 boys and the 2 girls. 90 and 90 would be 180, because 9 plus 9 is 18. That's a double. So 90 and 90 is 180. And then we still have 5 more boys and 2 more girls. They're going to be standing on the side of the road. Well, that tells me that there's not enough either. So I will say, no, there are, and I can actually tell you exactly how many there are too many, because my 90 and my 90 here made 180. There are 7 more students who will need a seat. So I don't know how they're going to do that, but that's not something we have to figure out. We just need to know if there's enough. So if I were the teacher organizing this, I would be able to just estimate. I wouldn't have to go, okay, well, 95 plus 92 and add it all together. I can say, well, gee, 90 and 90 is 180 right there. Oh, we're going to be over. Look at that. And I didn't even know exactly how many we had. All right, look at this one. Mrs. Carpenter received a bill for car repairs. About how much was the oil change if the other repairs were $102? Okay, well, there's that word, about. That means I can estimate. I also need to use the information by the picture, don't I? So the whole repair was $134. Everything except the oil change was $102. So I think what I can do is I can do an estimate. 134 is about 130. And then I'm going to take away the fact that the other repairs were about just $100. So the oil change would be about $30. So about how much was the oil change? The oil change was about $30. And notice I labeled it. All right. So sometimes we did exact. Sometimes we could estimate. If it says about, let's estimate. If it's a yes/no answer, let's estimate. If it actually asks you how much is something, well, then you need an exact answer. All right. Now, the explaining can be sometimes the hardest part. But I want you to do for your assignment, it's pages 149 and 150, but 149 is just a sample question. So really, you're just doing page 150. All right. So for each one, it says, it says, let me get it there. There we go. Determine whether each problem requires an estimate or an exact answer, then solve. And please notice, they do want you to explain kind of what you were thinking when you do some of these. Okay? 3 of the 4 want you to explain. So think about what it was that you did to figure it out. Okay? Remember, yes, no questions, you can probably estimate. When it uses the word about, you can estimate. If it asks you how much or how many more, then you're doing the exact answer. All right, so just this page, and I bet you can do a great job. Remember, read things through more than once. You might have to look back at it. You may have to make a little picture. You may have to do little bits of something first, okay? But you'll be able to do it if you take your time. All right, have that done for tomorrow.